Hello, welcome to our presentation today. This is DFT 170 Engineering Graphics, taught by Dr. Hans Chapman in spring of 2022 at Cape Fear Community College. Our project is design a Vise using SolidWorks, and the participants in this project were Clayton Scott, Ray Schwartz, and David Hollick. This is the item we chose to model. It's a standard 6 to 8 inch bench vise. Students were allowed to take a field trip around campus and pick items that they would be interested in modeling. After picking the item, we took careful measurements, made sketches, and then brainstormed so we could effectively model this project.
For the main body of the vise, we outlined an actual vise, got to our desired dimensions, extruded some parts like this part right here, and shelled the inside.
Figure 2 shows the extendable jaw. For this part, the shell feature was used to hollow out the inside of the part and remove the bottom and back of the jaw, leaving half-inch thick walls on all sides.
This is the bottom of the vise, which consists of the fixed base and the inner ring. Figure 3 shows the bolt-down base, which allows this to be fastened to any surface. And Figure 4 shows the swivel ring, which will allow the top of the vise body to attach and then swivel 360 degrees and then be fixed in position.
Figure 5 shows an assembly of the vise with all parts mated and the vise in the fully open position. Figure 6 shows the same assembly of the same vise, but with the jaw of the vise moved in to demonstrate the fully closed position. For this assembly, a mixture of coincident and concentric mates were used to mate the parts together and prevent them from simply passing through each other when moved.
This is our drawing document. We chose the vise body for this document because it had the most detail. It has the standard 3 views and isometric view. We chose our top view, our front view with the most detail, and then our right view, and then filled in the associated information such as materials.
Simulating the vise, we decided to make the manufactured product out of alloy steel. The alloy steel is already pretty resistant to deforming, but to show where the vise would take a load, we also simulated it in a softer material, in this case lead, to show where the vise would deform.
Figure 10 demonstrates the vise in operation. You can see the vise open and close corresponding to the rotation of the center shaft. Figure 11 demonstrates the vise with parts exploding outwards. You can see the jaw move out of the vise body. The shaft comes out of the jaw. Then the vise body rises upwards to show the bolt-down base, and finally the inner swivel ring comes out. To conclude, we feel like the most difficult part of the project was communication and units. At the beginning, every member of the group was actually working in different units. Because of this, near the end we had to scale all of the parts in order for them to fit each other, which took a lot of time. This could have been avoided if the members of the group had communicated more effectively near the beginning of the project.